Welcome to Session 12, Cones and Spheres. We will build the idea visually, solve a complete example, and finish with a short independent check. By the end, you will be able to relate a cone to 1/3 of a matching cylinder, use radius cubed correctly in the sphere volume formula, read a formula sheet carefully and substitute only corresponding measurements. Keep the diagram, the calculation, and the unit connected at every step. Start with the concept visual. The sphere volume uses radius cubed. The matching cylinder makes the cone's 1/3 factor visible. Read every label as evidence about what is known, what is unknown, and which measurements actually belong in the model. Here is the central reasoning. A cone and cylinder with radius 3 centimeters in height, 8 centimeters have volumes 75.36 centimeters cubed, and 226.08 centimeters cubed, respectively, using 3.14 for pi. The exact 3-to-1 comparison verifies the cone calculation. Cones and spheres require careful formula substitution. A cone with the same base and height as a cylinder has 1/3 the volume, giving a useful comparison before calculating. Draw or imagine a cross-section and decide whether you are filling the solid or covering it. This separates cubic volume from square surface area. Now add a precision check. For a solid, mark the base and the perpendicular height, then separate flat faces from curved surfaces. Keep pi or other exact values through intermediate steps. If the object is open, attached, or partly hidden, count only the faces the context says are exposed or filled. A complete line of work should make the diagram, formula, substitution, arithmetic, unit, and conclusion easy for another learner to audit. Use this repeatable method. First, identify the radius and, for a cone, the perpendicular height. Second, write the complete formula before entering numbers into a calculator. Third, for a cone, compute the matching cylinder volume and divide by 3. For a sphere, compute pi r cubed and multiply by 4 divided by 3. Finally, use cubic units and compare the cone with its matching cylinder as a reasonableness check. Do not skip the final check simply because the calculator produced a number. Let us model a complete example. A cone has radius 6 and height 5. Using pi equals 3.14, what is its volume? Step 1 is to organize the information. Identify the radius and, for a cone, the perpendicular height. Step 2 chooses and sets up the relationship. Write the complete formula before entering numbers into a calculator. Step 3 carries out the mathematics. Cone volume is 1/3 of par squared h, 1 divided by 3, 3.14, 6 squared 5, equals 188.4. A useful check is to divide the matching cylinder volume by 3. The answer is 188.4. Now verify the result against the original wording. The quantity, numerical size, and unit must all make sense together. Now it is your turn. A sphere has radius 9. What is its volume in terms of pi? Write a formula or relationship before calculating, then use the next 6 seconds to finish your reasoning. The model answer is 972 cubic units. Sphere volume is 4 divided by 3 pi r cubed. With r equals 9, 4 divided by 3, 9 cubed. Pi equals 972 pi. A useful check is to a sphere uses r cubed. Use this coaching check as well. Box the fraction in the formula before substituting. The most common cone error is a correct cylinder calculation with the 1/3 omitted. Session recap. First, identify the radius and, for a cone, the perpendicular height. Next, write the complete formula before entering numbers into a calculator. Then, for a cone, compute the matching cylinder volume and divide by 3. For a sphere, compute pi r cubed and multiply by 4 divided by 3. Finally, use cubic units and compare the cone with its matching cylinder as a reasonableness check. A strong geometry solution is more than arithmetic. It identifies the requested quantity, represents the structure, calculates carefully, and checks the meaning of the result. Carry that full habit into the next session.